Today I will be talking about hydrophobicity and the lotus effect. This picture you are currently seeing is a zoomed in picture of a lotus leaf. You can probably see a difference on the surface. It seems a bit bumpy, and the water on the leaf is not soaking the leaf wet. It is forming like a bead. This lotus leaf, when it is tilted, and these waters will roll off the leaf and it will not stay on the leaf. This is caused by the hydrophobic surface on this leaf. Just in case, for people who doesn't know what hydrophobic means, it is basically hydro, which is water, and phobic, which is fearing. So it is basically water fearing, or it does not get well with water. One example of this can be oils and waters. Oils are non-polar molecules and waters are polar molecules, and polar and non-polar molecules don't go together, and so they separate when you have both cups, oil and water, mix them together and they separate. And this is one of the examples. Now, back to lotus leaves. Lotus leaves are coated with waxy materials, which helps water to get repelled. And not only that, but if you look carefully using a microscope, the surface of the leaf, you will see small bumps everywhere. I have prepared a figure, so let us take a look at that. Now, if you take a look at this drawing, I'm not the brightest drawer, so please don't judge me. But you can see that if you magnify the leaf surface, you can see that there are bumps. And the water droplet is on the bump, and it's on the tip of the bump, and this is basically what the lotus leaf is doing. The reason why the bumps help the hydrophobicity is because of the trapped air between the bumps. When you compare the adhesion between the water, solid, which is the surface of the leaf, and air in between the bumps, water and solid has more contact or more adhesion, which causes reduced adhesive force of water droplets. I have not confirmed this, but I personally think that this is probably because of the surface tension of water. Dust particles are everywhere, and they are also on plants. When the dust particles are on plants, it will reduce the efficiency of photosynthesis the plant can do. So this hydrophobicity effect on this lotus leaf can allow the dust particle to be washed away or be removed, which allows more efficient photosynthesis for the lotus leaf. So we have seen how microscopic structure of the lotus leaf contributes to the hydrophobicity of the leaf. Now, scientists have discovered different ways of how these lotus effects or the hydrophobicity can be manually made by humans. One of the examples I researched was a silicon wafer. It was made hydrophobic by dipping the silicon wafer into a solution of stearic acid several times, allowing the solution to crystallize on the surface of this wafer. These crystals are kind of like the bumps on the lotus leaves, and the wafer became hydrophobic, and scientists actually dripped water and it repelled water. We can use this technology of hydrophobicity in different places. This water repelling effect can be used on windows, for it will be easier to clean, for no watermarks will be left behind after rains or storms or typhoons, because the dust particles, the rain, just drops off the window because of this effect. Or car windows will also be a good place. The driver doesn't have to worry about wet windows. This is a water repelling spray, and you can use this spray by spraying them on whatever surface you want to use on. And the surface will be hydrophobic, allowing that surface to not get soaking wet. However, this product has actually several dislikes according to the review section of the Amazon reviewer. The problems this spray causes are: the coating does not last for long, which means you have to spray it again and again, which means you have to buy it again and again. And the coated surface is kind of sticky, and it is not applicable on electronics or other hand-holding materials, just like the promoting video of this product showed. And it is said that this spray itself has kind of a whitish color, so whatever you spray this on, it will change color to kind of whitish. So if something is transparent, maybe it is not good to spray on it because it will change color. So after researching this, as an application for problems we might have in the world, I propose a better water repelling umbrella. All umbrellas we see now does repel water, but it will still be wet when you close it. We have all experienced it. Whenever you have to go indoors after the rain with an umbrella, you have to shake the umbrella to make it dry enough to bring them in, because the water droplets stay on the umbrella and you have to shake them off because it will still be wet. However, by coating the umbrella with super hydrophobic coatings that last long enough, we get to see a drastic improvement, because the super water repellent surface rolls all water droplets off the umbrella surface, allowing the umbrella to not get wet anymore so that you can bring them in easily without shaking all the water droplets off. I personally think that this application is pretty simple, but I don't think I see them actually applied and sold as a product. Or maybe there are, but I have never seen them before. And this small problem is actually pretty annoying for some people, for like me. And I think this will probably make the lives of a lot of people easier in rain. And this is the end of my presentation, and thank you guys for listening. See you guys next time in my next video. Bye bye.